Hello, hello, hi everyone. Let's go ahead and start the group work videos, or the worksheet video. Number one reads, if an is equal to n factorial and an plus 1 is equal to n plus 1 factorial, find an plus 1 over an. Simplify as much as possible. Okay, so that's going to be n plus 1 factorial over n factorial. From here, it just seems we're going to use that definition of factorial. We expand this a little bit, cancel that out, and you have n plus 1. Then you have if an is 2n factorial and n plus 1 is 2 times n plus 1 factorial, which is 2n plus 2 factorial. And finally that quotients. Same quotients. I was going to rewrite it, doesn't matter. We have 2n plus 2 factorial over 2n factorial. So that we're just going to count down till we get to 2n factorial. So we have 2n plus 2, 2n plus 1, and then lastly 2n factorial over 2n factorial. Cancel this out, and you're left with 2n plus 2, 2n plus 1. If n is equal to 3 to the power of n times n factorial, and n plus 1 is equal to 3 to the power of n plus 1 times n factorial, find an plus 1 over a. So we have 3n plus 1 times n plus 1 factorial over 3n times n factorial. We know this will make this guy just go to 3 because there's 3, 1 left. And then this, as we know from there, will just simplify to n plus 1. So we have 3 times n plus 1. All right, next, determine if the sequence converges or diverges. If the sequence converges, determine its limit. Okay, so from here, we start with n is equal to 2, but we see that either way, we're going towards infinity, and we have this guy and this guy. Determine that both the degree at the top and the degree of the numerator is 2, and that's a balanced equation. So we're to write it like this, 3n squared minus 1 over 5n squared plus 10n. That's simply just 3 over 5, using the logic of a balanced equation. All right, next we have determined if the sequences converge. Oh, I don't know why I rewrote that. B. Okay, so over here, I'm going to go ahead and first write it out as its limits. And I think I'm going to do Hospital's rule, just because that's not directly, you can't directly combine these exponentials, but if I do L'Hopital, which I know I can because both of these will go towards infinity, I can just manipulate it that way. So let me first write it out. Okay, wait, no, sorry. So if we do less hospital rule, because the bulk will be towards infinity over infinity, you get, what's that, 5e to the 5n over negative 2e to the 2n. There you can combine the exponents. Wait, I keep forgetting the right limit. So we have negative 5 over 2, and then times e to the power of 5n minus 2n, which is just 3n. E to the 3n. We know that this term is going to go towards infinity, but this negative flips it and makes it go towards negative infinity. Here with these two limits though, we need to actually answer the part of it converging or diverging. Top one converges because it actually goes towards a number. The bottom one diverges because it does not exist to go towards negative infinity. All right, fine. Write the partitions of the following n. So you have n is equal to 6 and n is equal to 7. Okay. I'm going to start with the easy ones, just 6 and 7. And then let's take a 1 out and see how many 1s we can take out. So 1 plus 5, 1 plus 1 plus 4, 1 plus 1 plus 1 plus 3, 1, 1 plus 1 plus 1 plus 1 plus 2, 1 plus 1 plus 1 plus 1. So basically we just have 6 ones. Okay. Now I'm going to take out a 2, so 2 plus 4, and then 2 plus 2 plus 2. And then I'm going to take out 3, so we have 3 plus 3. Trying to see if we could take out more. I don't think you can. Okay. Alright, I'm gonna just, before I get too cocky, I'm gonna double check my answers. Oh, that's right. Okay. And then from here, technically, I forgot about turning these into the 1 plus 1s, so that's on me. Okay, so we know we could turn this to 1 plus 1. Here we could turn one of those into 1 plus 1. And then here we could turn that into not all 1 plus 1s, but definitely 1 plus 2 plus 3. What do I have them all? I think the answer was 11. Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So let's see 11. Okay. So now let me try to do this one. Uh, let's see. 1 plus 6, 1 plus 1 plus 5, 1 plus 1 plus 1 plus 4, 3, 2, and then all the ones. Okay. Now I'm going to take out the 2's. So 2 plus 5, 2 plus 2 plus, um, what is that? 3? No, yeah, 3. And then 2 plus 2 plus 2 plus 1. And then you can start turning these into plus 1s where you have 1 plus 1 is 5. We technically don't have 1 plus 1 plus 2 plus 3. Here, I'm going to turn one group into 1 plus 1, so 1 plus 1 plus 1 plus 2 plus 2. And then if I turn that second one, it's just a matter. Okay, then I'm going to start at 3, so 3 plus 4. That 3 can get turned into, oh wait, I could do one more 3, so 3 plus 1. And then I can turn both of these 3's into 3 sets of 1, which I already wrote that one over here. And I already wrote that one over there. But let me turn to 1 plus 2. So 1 plus 2 plus 4. And then 1 plus 2 plus 3 plus 1. Oh, wait, I already wrote that over there. So that doesn't count. All right. And I think that's it, because you start looping and you go back to 4. Let's see. Did I do it right? Got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 14, 15. I think the answer was 15, but let me double check. Yep, 15. Six. Right, last one. Find the k partial sum limits. So we know that this is better served. We write it as the limit as k goes towards infinity for k n is equal to 1, 2, n plus 2. From here, we're going to try to do the telescoping trick. So it's 2, oh, I'm sorry, a over n plus just b over n plus 2. So that's going to be 2 is equal to a n plus 2 n a plus b n. That 2a is equal to 2, so a is 1. And then that means b is negative 1. Because a plus b is 0. Okay. So now we can definitely just have it be similar and expand the limit. So we have 1 over 1 minus 1 over 3 is equal to 1. Then we have 1. Oh, wait. I wrote a huge one. 1 1 over 2 minus 1 over 4, but n is 2. And so far, we're not seeing anything cancel out yet. But I know when I do n is 3, I'll have at least this cancel out. But let's see what else happens. 1 over 3 minus 1 over 5. 1 over 4 minus 1 over 6. So it seems like it'll cancel out. It didn't cancel out these two, but now that they start repeating, we can go ahead and keep it going indefinitely until we get to n is equal to k minus 1. So 1 over k minus 1 minus 1 over k plus 1. And then plus for n is equal to k, 1 over k minus 1 over k plus 2. And then from here, because we're assuming that it'll get rid, so for example, n4 will get rid of here. For this guy, it got rid of in, let me see, I'm trying to, because this number will repeat when k minus 3 is mentioned, so that does cancel out. Here, I'm gonna do that a little bit, just a little bit on a side note. So we want to see if n is equal to k minus 1. I'm sorry, wait, I wrote that wrong. Oh, no, I didn't. We'll see when n is equal to k plus 1, and when n plus 2 is equal to k plus 1, that means when n is k minus 1, which will happen because n is counting up. But for n, we don't exactly go to k plus 1, so that does stay. Same thing for over here. When n is k, we have that, but when n2 plus is k, we know n can be k minus 2, which does come up. So that one cancels out for sure. And we're just left with these two. So if we're left with those two, that means we have the following. So we have these two stay and these two stay. So we have this limit, or the limit of four terms, right? We have the 1/2, and then the one negative, not negative, minus 1, k plus 1, and minus 1 over k plus 2. And here you can technically just take the limit piecewise of all four terms. We know that's going to be 1. That's going to be 1/2. That bottom heavy is going to be minus 0. That bottom heavy is going to be minus 0. And you're left with a limit of 3 over 2 or 1.5 as your final answer. I'm sorry. No, well, yeah, limit. Even I was going to say it doesn't converge. But I said limit out loud. So 3 over 2. And what does it converge to? Oh, well, it's bottom heavy. So it's going to converge to 0. But we have the proof that via its sum, it's going to converge. Okay. This one's a bit uglier. But I mean, we can mess with these and manipulate the math a little bit. I'm thinking about how I'm going to ask you these on the test, but I might give you a hint. I might say use ideas like geometric series or use ideas like telescopic series. That might be what I do. It depends. There's still more to go. And this is also going to be a test. It's going to combine Unit 4 and 8. Wow. So I definitely do have to, it's in my best interest and technically yours for sure to streamline this as much as possible. But yeah, all right. That's going to wrap up today's lecture. Let me know if you guys have any questions. I will see you all in the next video. Bye bye. Be safe.